Okay, token. So there are quite a lot of endpoints in here, and I'd imagine that there will be more that are added to all of this Web3 API section as time goes by. But we'll go through each one of these, and again, I've built them into this application over here. Let's just close the console, move over to our Web3 API token, and I've just put them into an accordion of sorts, just so we can see, and then built some examples that we can go and find to get the data. So starting off, the first one, get token metadata, returns the metadata for a given token contract address. It's asynchronous, and the data that you'll get back will typically be the name, the symbols, the decimals, and the logo. An example would be this one here. This is the address. This is the example object result that you would get back. Be aware that this is specifically for tokens. It's not for NFTs. It would be for something like a coin or a token of some sort. Kylan Network is the example result that we have down here. It provides back the name of the token, the symbol, how many decimals it would have, and some other information as well. Up here, we've got two examples that we could use. The first one is getting the metadata for a single token, and the second one gets the metadata for an array of tokens. So you can pass through an array in the addresses field if you wish to. But it's the same idea as before. You build your options object, and then you pass that options object into the function. It saves it into the variable, and then you would handle that the way you would want to on your front end. Let's go and take a look at some examples. If we move over to here, we have the chain. Let's choose some ETH examples. We've got an address here we can search for. So let's choose ETH mainnet. We'll put the address in there. We'll search. I don't think it's going to populate on the front end. It will just be in the console, I believe. Here we are. There's an array of one result, wrapped ether. That is the name of this contract address. Let's just try another couple. That one is the curve DAO token, and we'll just do a final one. Let's just search on Ripston, and we'll just search for this address. And we'll scroll down. The result is here, and that is DAI on Ripston. The code would be this. So we are just collecting the information from the front end, saving them into two variables, passing those variables into our options object, and then passing our options object into a single line of Moralis code. And then from there, console logging the metadata. Super straightforward function. And that is get token metadata. Let's move on. Back to the documentation. Get token metadata by symbol. Pretty much the same idea here. You're going to get the metadata, whereas the previous one was searching for the address. This particular one will allow you to search by the symbol itself. So in this example, you have a search for link. In the second example, you have an array of symbols that you could search for, and it's looking for both link and Aave. You build your options objects as before, and then pass it into this function. This would be the example result that you get, which is pretty much the same output that you had previously. It's just the way you searched for it was different. Before you searched for the address, and now you're searching by symbol. Let's go and take a look on the front end. Scroll down to get token by metadata symbol, and again, bearing in mind that there are multiple different tokens that have been set up here, you might find more than one result. For example, if I choose link and then search on, let's say, Rinkaby, and then get NFT transfers, 635 different link tokens, which is crazy. So how would you know which is the correct one? But if you've got your own token or a different token that you know is only going to return one, then this is a way to get that information. But if you know the address, it might be better to just use this previous endpoint here. If we move over to the code, it's the same idea as before. You build and get the information from the front end, as I have in that case. I built my options object and then just call it. Console log the details afterwards. Nothing difficult at all. Single line of code for that one. Okay, let's go back to the documentation. Get token allowance. That is the amount the spender is allowed to get from the owner of a contract. Now, I can't demonstrate this example because I don't have a smart contract to demonstrate that has a pre-approved spender owner set up, so I can't go and query this. But in your example, if you're running a marketplace or you have some application where you are already in, where you already expect this to this allowance to be approved, then this is a way to do that. You run an options object with the owner address, the spender address, and the token contract address, and perhaps define the chain as well. Pass it in, and you will just simply get an allowance back, and that will be the amount that they will be able to withdraw. If the spender is not approved, then you won't get an allowance back here. So you've got to have a smart contract that has a spender approved within the logic of the smart contract. Okay, so I'll leave that one to you to explore further. Get token price. Now that's an interesting endpoint because that actually will allow you to go and get the price nominated in the native token and USD for a given token contract address. Now, getting a contract token address might be difficult to do, but there are websites that you'll be able to do that. For example, if I go over to my front end here, in the get token price accordion, I have a link that we can go onto, and this will give you, for example, Aave's token list. And in here, there's sort of 80 tokens with all the different addresses, for example, for DAI stablecoin, USDC, Tether USD, whatever you might want to look for, Chainlink token, Kyber, MakerDAO, and you could just click on any one of these and go and collect that. Now, the chances are there's a source code as well, so you could probably go and get the JSON. Yeah, you could. So you could actually go and export the JSON, put that into your JavaScript, and then you could do a for each loop around that information and build it or enumerate it in some way into like a drop-down list for the users. So that's doable, but I haven't done that in this example here. I've just copied a couple of them to put in here. So if we choose DAI first of all, and then just search for that, it shows us that the price is 99.7. USDC, well, that's another stable coin, as is USDT. So let's try a different one. That's going to be Link. There we go. It replaces the price, and Aave would be there. Okay, good. Now, the code itself is a simple function. Here it is. It collects information from tokens. So, there we go. I have just a simple click listener here, which listens to the HTML button. And then on click, it runs a function called getTokenPrice, and it passes in the value that we put into that input field. So that's pretty straightforward. And then in here, with that data from the input field, we will pass it through moralis.web3api.token.getTokenPrice as an options object, with address being the token. And that's it. And then from there, we just handle that and print the information into the HTML on the front end. And that's getTokenPrice. Super simple, isn't it? So these are great endpoints, very powerful. They do a lot of work behind the scenes. And this particular one, getTokenPrice, I did actually only pass through an address parameter here. I didn't actually pass through an exchange name or the chain. Now, so that meant it defaulted to ETH for the chain, but the exchange name, if you don't pass an exchange name, then all exchanges are checked in the order listed above. So it starts with Uniswap, then Sushi, so on and so on, so on. And it searches all of them until a valid one is found, but just be aware that it can take more time to do that. So that's getTokenPrice. Let's move down to get all token IDs. So what's get all token IDs? Well, this endpoint might take a while to search for because this is actually going to return all of the NFTs that are attached to a particular contract address. So for example, if you are on OpenSea and the contract address for OpenSea might have hundreds of thousands, maybe millions of NFTs, it's going to go and return an object with all of them in it. And the NFT metadata will actually be resolved as well. So that's going to take a few seconds to come through, but it's incredibly powerful. It requires just a couple of options: the chain that you want to search on, the default is ETH, and the address. Standard stuff. You build your options object, you pass it into this particular function, and it will return a result like this, maybe hundreds of thousands of times, depending on which contract address you search for. So the metadata is the thing to be aware of here, because that needs to be passed if you want to use it. So just run a JSON.pass around the metadata, and then you can just simply use it. It's all resolved, ready to go. You don't need to fetch the metadata from the token URI. If you're still fetching data from a token URI, then stop it and use this instead. If we take a look at it on a front end, the Binance Smart Chain, paste in there. If you press get token IDs, this might take a second. Oh, okay, it wasn't too bad. 481,000 of them. It separates it into pages, and page size is 500. So handle that however you want to by paginating the pages. And the data is, as it said in the documentation. So they are the NFTs with all of that information with fully resolved metadata. The code for this one is pretty basic. In fact, it's one of the most straightforward ones. I've just got the information from the front end, passed it into an options object, passed it through the function, console logged the result. That's it. Okay, let's go back to the documentation. Get NFT metadata. It sounds like it's pretty similar to the previous one from get all token IDs where we had the resolved metadata inside here, but it's not. The metadata that was resolved inside the previous one was for each individual NFT, whereas this particular endpoint is contract level. So it would be the NFT metadata, for example, from Pancake Bunnies. That will be Pancake Bunnies metadata rather than the individual NFT that is included within the contract address. So when you pass through that contract ID into this particular endpoint, it will get you the metadata for specifically Pancake Bunnies. Okay. Again, if you search for this particular contract address and it doesn't exist yet, then it will start the index processing for that NFT collection. To use the NFT endpoint, you only really have two parameters that you can pass through. Build an options object, pass it into this particular function, and then use the data however you want to. In the front end, this is how it would look. You just copy in that contract, put it on Binance Smart Chain, run a search, and it will provide you with, it's still got the previous one. Let's just clear that. There we go. Provide you with the contract level metadata for, in this case, Pancake Bunnies. Okay, let's carry on. So down to get NFT owners. This one's interesting because when we use the order option on this one, you can actually pass through more than one. You just separate it by a comma and you'll be able to do fieldname.asc, comma, fieldname2.desc, for example. So in the order, you can pass a couple, but this particular endpoint just simply returns an object with a number of NFT owners and an array of the NFT data as well for a given token contract address. There's a number of different options you can pass through. The usual two apply, so the chain and the address. We also have format, which was for the token ID, if you remember, in decimal or hex. The offset and the limit we've seen before, and the order will just simply allow you to sort them. Building the function is much the same way. This is asynchronous, and again, we can just build our options object, pass it through our function, and then we will be able to work on the data that comes back. And there's a couple of other examples of how you can use this function. And also the order option, actually in this example, has two that you can see for yourself. Okay, when you get the results back, they'll look something like this. And it's probably a good idea if you are going to be using the order option to actually use block underscore number is the best one to do, as it says here. So let's go and take a look at that in the front end, and we go over to the app, get NFT owners. I've got a couple of examples here for Rinkeby, Polygon, and Binance Smart Chain, and I've also got an example of the ordering here to show you how you would use that. So if we look at the Rinkeby one first, let's paste that in here, and then choose Rinkeby. Do a search without any ordering first, and you can see there's 6,200 results down here, which it limits it to 500. You'll have to do some pagination, and that's where your data would be. The metadata is already resolved. So again, just make sure you run json.parse on that metadata, and you'll be able to use it in your application. If you wanted to then order it so it's slightly different, so for example, it orders it by the block number, then you just simply put those that data into your search field like that. Inside the code, it's the same as before. The majority of this is just getting the information from the front end, building the options object, calling the function, and then console logging it. Very straightforward. Okay, let's go back. Search NFTs is one of my most favorite endpoints in this entire SDK because it allows you to do so many things when it comes to NFTs. It allows you to search, go and get all of the information across the metadata of an NFT. And a use case I've particularly used this with recently is checking the authenticity of an NFT, checking the minter's address against the address that you believe it to be to see whether or not the NFT is authentic. Fantastic use cases that you can build from this. So it's a tool that enables you to get NFT data based on a metadata search. It's asynchronous and it takes in a number of options. So let's take a look through the options. We've got the chain, which is normal. The default would be ETH. Format, again, that's going to be based on the token ID and it's dependent on being either a decimal or hex. You have the offset and the limit we've seen many times before already. And these two are new. So Q is the string search parameter. So say, for example, you want to search for CryptoPunks, then Q would be the string that you would use to search for CryptoPunks. Filter That enables you to choose what fields within the metadata you want to search for within that NFT. So perhaps you just want to search in the description of the NFT, or maybe you want to search the name in the NFT. Maybe you want to search the description and the name, or perhaps you just want to search in the attributes of the NFT if it has any. Global will give you the option to choose the whole metadata set, or you can choose individual ones or combinations of 2 or 3 of them together if you prefer. So that's the filter. That's super useful. When you call that, again, you build your options object, you pass it into the function, and it will return an object of information. And again, super simple to use, one line of code. So let's go and have a look on the front end. Let's load it up. So scroll down to search NFTs. If you've noticed these errors down here, this is to do with the 1-inch plugin. It's missing a couple of images for the decks, which is something it's not going to be covered in this course, but you can ignore that. Okay, so we're going to search on the Ethereum mainnet. We're going to search for Moralis. I've searched for this before. And we're going to search for the name field. It brings up 3 different NFTs here. Let's just expand them all. The first one is this one here. It's not one of ours. That minter address A9A is not ours. So that is an not authentic Moralis NFT. However, Moralis Monastic, which ends in EA8, is, and also Moralis Mogul also ends in EA8. You can see by the minter address here. You can do a very, very simple check when you do this search. Check it against an address that you know is genuine, and if it's not matching that, then you know that the NFT is not authentic. And that is just a very powerful use case that you can use this particular endpoint to check whether you're actually dealing with an authentic NFT or not. And so I've just searched in name, but I could, for example, search global. I haven't actually done this with Moralis. I don't know what's going to return. It returns 11. So you could go through each one of these and just take a look, but I'm probably not going to do that. Maybe some of them are genuine, maybe some of them are not. Maybe I'll just check on Rinkeby. Let's just have a look and see what comes up there. Minimize that. So there are 7 on Rinkeby. Some of them actually will be mine because I remember creating some NFTs on Rinkeby myself, so it might be worth having a look through those. But so that gives you an idea of how you would use the search. The limit, the offset, and the format, I don't really tend to use, but you can. But the fields that you choose to search by could be super, super useful. And of course, you can search whatever you like. CryptoPunks. I'm not sure if that's one word or not, actually. If we do a search for that, see what comes back. That's okay, 66,000 results. So what you could perhaps do on there is then go through and have a look at a search against the minter's address, and you'll be able to see which ones are genuine or not. So again, super, super useful. If we go and take a look at the code for that one, there's probably a little bit more to this one. Wait a minute, what am I saying? Of course there isn't. It's Moralis. It's all super simple. It's just one line of code. So the first bunch is just collecting the information from the front end. The second bunch is building our options object. And then we've got one line of code, passing in that options object, and then we console log the results. How easy is that? Okay, let's head back over to the documentation. Get contract NFT transfers. We're nearly at the end of this section. If you need to find the number of NFT transfers, get an array with the NFT transfers for a particular contract address, then this is your endpoint. And again, the build is exactly the same before. Options object, pass it into the function. You get your output that would look like this. All sorts of information in there that you can use and query. The parameters, there's nothing in here that's new. We do have the order again in here, and the order can also be split into 2 separate ones, so you can pass across 2 if you need to. But everything else is the same. Make sure that you pass in an address. The chain will default to ETH if you don't select one. The format is for the token ID, and offset and the limit you can choose for the result output. Let's take a look on the front end. Okay, so get contract NFT transfers. Let's just tidy up the console down here. I've got an example of an address for Binance Smart Chain. So let's just choose that, paste that in there, and then do a search. See what comes back. Might take a second. Okay, there's over 1 million results there, so I'm certainly not going to spend any time going through that. But you'll see when you go into it that the results will provide you with this information. And once you've got that information, of course, you can do searches on the address that it came from, the address that it was going to. You could also do a search based on the blocks that it was included in, or a date range. You could build that into your own front end and query it however you wanted to. And the last 3 then, so get token ID metadata. That's useful if you already have the token address and you just want to grab all of the metadata from that. It's cross-chain. You could do it across all of the different ones, ETH being the default. You'll need to make sure that you put in the token ID, otherwise it will fail, and the contract address of the NFT as well, otherwise it will not work. The format is related to the token ID, whether it's decimal or hex. And you build your options object and you pass it in through the function. It's exactly the same as it always has been. We've already seen get NFT metadata, but if you remember, that was a contract level metadata. So that was for the specific smart contract, whereas this now is the individual NFT's metadata given the token ID. I think that one's pretty straightforward. I can demonstrate it, but I think you'll get the hang of it pretty quickly. Get token ID metadata. I've got an example here on Rinkeby. So this will be the contract address. Go and choose Rinkeby and then paste the token ID in here. Make sure there are no spaces. Otherwise, if there's spaces at the end, it's going to mess up the string. Do a search there. Okay, that's all it was. So, and then we have fully resolved metadata from that particular token ID on Rinkeby. The code is simple. I haven't done anything other than just build the front end, pass it in through and then console log the result. Okay, get token ID owners, much the same as the metadata, except it's going to provide the owner's detail back instead of the metadata. There are a couple of other options included in here. So you have the format, the offset, the limit, and the order, which we've seen before. The address and the token ID are required, and the chain will default to ETH if you don't select it. Build your options object, pass it in through the function. You know the score now. It's always the same. There's a couple of examples here. One of them has the block number and the contract type in the order parameter. Go and take a look on the front end. A couple of examples here. I've got a Rinkeby one, so I'm just going to take that contract address, paste it in here, and choose Rinkeby. We'll take that. I think I also need to make sure there's no spaces. There's no spaces. Good. And let's just do a search on that first. Clear the console. Okay, it's just one that's come back there. One owner, it seems, of that particular NFT. And let's see if there's another example. I've got another one on ETH. 73 looks to be the token ID. Pretty different to the Rinkeby one, isn't it? Minimize that. Okay, there are 5 owners for this particular NFT. Okay, so go and do your own searches for that one. So that just shows the number of owners that you get back and gives you the details for them for that NFT. And the final one, get wallet token ID transfers. Returns an object with the number of NFT transfers and an array of all the transfers by token ID. And just looking through these parameters, they're all pretty familiar with what we've seen before. Chain, address, token ID are generally the main ones. And then the other one's format, offset and limit. And then with order, you again can pass through 2 if you like, depending on the field name. You could search any of these and just put ascending or descending at the end, similar to this example here and this example here. You build your options object, you pass it through the function, and then you can do what you like with the data. And this would be the example of the output that you would receive from that particular function. Again, if we take a look on the front end, and I've got a couple of examples here. I've got a CryptoPunk example. So on ETH, let's just choose that. Minimize this a bit. We'll take the address. And we'll take this number here, which is 6,079. Click transfer. I probably should have cleared the console. I'll do it again. Okay, so 8 times. Looks like this has moved around 8 times. So that's what this is telling us. It's giving us an information of the different addresses that this has changed from, and then the different addresses that this has changed to. So that particular CryptoPunk has changed hands these many times, and these are the details that you can look into. So again, if you need to use that in your application, that would be how you would fetch that data. Fantastic. So there we go. So that is tokens. So the next section we'll do is wrap up the rest of this by taking a look at the Resolve, DeFi and IPFS section. So on Resolve, this is quite interesting because what this does is it takes either an unstoppable domain or an ENS domain and returns an Ethereum address. So why is that useful? The reason that's useful is because when you're going through the Web3 API and you're putting in a token address, an Ethereum address, should I say, you can now replace that technically with a function that puts in somebody's address. So for example, instead of an Ethereum address, you could put in Brad Crypto and it will recognize that it's a URL or a domain and just convert that into its Ethereum address. Let's show you an example. And let's go down to the Web3 API, scroll to the bottom. I've built a little function here that is going to use our resolve API. So I've built a function that will be able to distinguish between whether it is a unstoppable domain or an ENS domain. I'll give you an example. If we typed in here brad.crypto, so it's an unstoppable domain, and we'll click resolve, it will say brad.crypto. That's the Ethereum address that it resolves to. If we were to put in something like vitalik.eth, is an ENS domain, we can search for that, and then it says vitalik.eth, that is the Ethereum address. Okay, so that's what it will do. So essentially, you could actually put this into your application instead of the Ethereum address, and it will automatically resolve to that as long as you've got a function similar to mine to handle it. If we go back to the documentation, it requires two options. The first one is the currency, which is what it wants to be queried against, and the available values are ETH or 0x1. The domain would just be the domain that you're going to be resolving to. Super simple one line of code as normal, and the example result will be the Ethereum address. There's a video here that shows how to use that in React as well, that was produced by Malik, so recommend watching that. And if we go over to the code, I've just built a function here called resolve domain. It takes the domain in, so when the button on the front end is clicked, which is this one here, it runs a function, it runs resolve domain, and it passes in a stringed version of whatever is in that input field on the front end. And then we've got some basic error handling. It checks whether there is a domain, and if not, it mentions to do so. And does it end with .eth? If so, do this try catch block here. And what we're going to need to do first of all is enable Web3. And then we're going to need to use a Web3 function that goes and gets the ENS address using the domain. And then it appends the text into the front end. And if not, it provides an error. If it doesn't end with ETH, then it goes to this else, which will try another try catch block, which then resolves using the Moralis function. And that would just pass in the domain into our options object here. And we've hard-coded ETH as the currency here. We pass that options object into this function. And then we append the HTML to our front end if it works. And if it doesn't, then we get an error and it would simply say, nope, couldn't resolve. And that's it. Super simple. And it will just enable us to find out what the Ethereum address is of either an unstoppable domain or ENS domain. Back to the documentation. If we take a look at DeFi, we've got two endpoints that we can use. We can get pair address and we can get pair reserves. Now, when you go and get the pair address, we need to go and put together two different tokens, token 0 and token 1 in this example. And then when you search for that using an exchange, say for example, PancakeSwap v2 on Binance Smart Chain, it will provide us back the address for that pair, which will be down here. That's important because if we then want to find out what the reserves are for that particular pair on that particular exchange, we need this address. So that's like the first step in order to use this endpoint down here. Okay, so as far as parameters are concerned, you'll need to provide two different token addresses. So if you remember back on our dashboard when we were looking at get token price, we had this link here, which enables us to go and get the contract addresses for certain pairs. You can get any two contract addresses from here. Let's say USDC versus Chainlink as an example. I may as well just do that as an example. And you take both of those, and then we'll scroll down to our... I don't have a user interface for this particular endpoint, but I have got the code which we can copy and paste into our console window here. And we'll bring up what it's found. There we go. So that's our pair address here. And if we open that out, we can see that we've got the details for each one of those two tokens and the pair address. We would then be able to take that pair address if we wanted to feed into our next example in the documentation, which would be getting the pair reserves. So to understand this endpoint, what we'd need to understand is what the decimals are for each one of the two pairs that we're using. Let me explain what I mean. Getting the pair reserves, you pass in the pair address that we previously got, and you pass in the chain that you want to search for. That's just 2 of the 4 options that I'm going to use. I'm going to ignore the toDate and the toBlock. So coming back, if you pass in the pair address from the previous endpoint and the chain that you're searching on, and then run that options object through the function, it will return this. But you'll need to understand how many decimals each one of those pairs had. So in our example, in the front end here, we were looking at die versus tether. Both of these examples here are based on 18 decimals. So if we go back to the documentation, these numbers, assuming that they were die and tether, which they're not, by the way, but assuming that they were, then you could divide these numbers by 18, and that will show you the number of tokens of that asset in the liquidity reserves, or in that liquidity pool. So that's what you have to understand, because sometimes, for example, if we're using USDC, I think that's only a 6-digit or 6-decimal pair. So you'll see that this number will be drastically smaller, let's say, than an 18-digit pair for that reason. So you just got to remember that. So if you wanted to put it in your application, maybe you could automatically divide this by the number of decimals from the previous function here. See, the decimals are included there. If we go over to our Ethereum token list, and let's just go and pick out USDC, dashboard, paste that in there, and go with Chainlink. Yeah, sure, why not? So USDC and Chainlink. Then we'll go over to the first endpoint here, copy this, the dashboard, paste this, change that, needs to be token 1, 0 and 1. Exchange, Pancake Swap. So the exchange is required, but I'm not going to be looking on Pancake Swap. I'm going to be looking on, let's go with Uniswap v2. Back to the dashboard, change that. So that's on ETH. And let's go and copy these numbers in here. It doesn't matter which order they go around. And then we'll try and search that. See what comes back. Excellent. So we've got a pair address there. Let's copy that. And then let's go back to our documentation and try the second endpoint here. Copy that. Be aware that this needs to be pair underscore address, not address. And if we just put this in here, pair underscore address, let's go and get the address in there, change that to ETH. And then search for that. So that's the reserves. And so for USDC, you have this. Sorry, for Chainlink, should I say, you've got this. And for USDC, you've got that. So in this particular example where we've looked at Uniswap v2, that's what's in the liquidity pool as far as the reserves. And you could then divide it by the number of decimals. So for example, the first one we know is 18 digits. So there's 47 Chainlink in the reserve there. And then we could check on the second one, number 1, and divide that by 6 decimals instead. And that's $1,400. So quite a small liquidity pool in this example. And that's how you would build it together. So you can go and search it and automate that however you want to, using the DeFi endpoints here on Moralis. So there are 2 there at the moment, and more will likely be added. So let's move that forward. The IPFS storage. Now I think this one's already been covered very recently by Philip. So take a look through this video. It shows you how to use the upload folder endpoint, and it's very detailed, and that's going to help you if you're looking to build a marketplace or something in that area. And that brings us to the end of this Web3 API walkthrough. I hope you've learned a lot. I hope there was information in there that has expanded your Moralis knowledge. And in the next series of videos, we're going to look through automatic syncing and databases.